Imagine a young Ethiopian doctor staring at a riverbank in 1964, watching women wash clothes with a humble plant, and in that moment, uncovering a natural weapon against one of the world's deadliest diseases. That man was Aklilu Lemma, a black scientist whose genius turned a common African soapberry into a life-saving molluscicide, a chemical that kills snails. His discovery saved the lives of millions plagued by a disease called Schistosomiasis, also known as Bilharzia. This debilitating illness, carried by snails in contaminated water, ravaged communities across Africa, Asia, and Latin America, infecting over 200 million people in 74 countries. Aklilu's discovery wasn't just a scientific breakthrough, it was a revolution, proving that solutions to humanity's biggest problems could come from the brilliance of a black mind and the wisdom of local traditions. Born in 1935 in Jijjiga, Ethiopia, Aklilu entered a world rich with culture but burdened by challenges. Little is known of his early years, but his thirst for knowledge carried him to the University College of Addis Ababa, later renamed Haile Selassie I University, where he studied the core sciences. His journey didn't stop there. In the late 1950s, Aklilu crossed oceans to the United States, earning a master's degree from the University of Wisconsin in 1960. But it was at Johns Hopkins University in Baltimore where he truly forged his legacy, securing a doctorate of science in pathobiology in 1964. Back in Ethiopia that same year, 1964, Aklilu's life changed forever. While observing women washing clothes near a stream in the northern town of Adwa, he noticed something extraordinary. Downstream, from where they used the Endod plant, known locally as soapberry, dead snails floated in droves. These weren't just any snails. They were carriers of the parasitic worm that causes schistosomiasis, a disease that scars organs, stunts growth, and kills slowly if untreated. Aklilu's sharp mind connected the dots. The suds from this plant, which African women had used as soap for centuries, were a potent snail killer, a natural molluscicide. He didn't just marvel at it, he acted. Returning to his lab, he tested his theory, and by 1966 he presented his findings to the world at a science forum. The Endod plant could wipe out the snails at a fraction of the cost of expensive chemical treatments, offering a poor man's medicine for a poor man's disease, as Aklilu himself would later say. This wasn't a one-off fluke. Aklilu poured his soul into perfecting this discovery. In 1966, he founded the Institute of Pathobiology at Addis Ababa University, where he led a team to systematically study Endod for the next decade. By 1974, he teamed up with his colleague Dr. Leges Walder Johannes, and together they refined the plant's potential. Their work showed that a chemical in Endod, later named lematoxin in Aklilu's honor, could combat not just schistosomiasis, but also vectors for malaria, guinea worm, and river blindness. Field tests were staggering. Among 3,500 children aged 1 to 6, infection rates dropped from 50% to just 7%. This was no small feat in a continent where resources were scarce and foreign skepticism loomed large. Yet Aklilu persisted, battling biases from industrialized nations that doubted an African solution could outshine their costly alternatives. His brilliance didn't go unnoticed. In November 1989, Aklilu and Leges stood before the Swedish Parliament to accept the Right Livelihood Award, often called the Alternative Nobel Prize, for their relentless campaign to make this affordable preventative a global reality. The University of Toledo in Ohio granted him an honorary doctoral degree in 1990, recognizing his work with the United Nations. Aklilu's vision even sparked a US patent in the 1990s for an Endod-based molluscicide to control zebra mussels in American lakes, turning his discovery into a potential cash crop for Africa. Sadly, he passed away in 1997.